Alright, hey! Today I'm going to show you how to convert from particles to mass, or from mass to particles, using those conversion factors that we've talked about previously. So if you want to, you can even pull up your mole map and follow along on using the mole map. Alright, so we have here 5,620 atoms of iodine. How many grams are in 5,620 atoms of iodine? Well, if you'll recall that 1 mole of iodine is equal to Avogadro's number of atoms of iodine. And since we're talking about grams, I know that 1 mole of iodine is equal to, on the periodic table, the mass, 126.905. So we've practiced going from things or particles to moles and moles to particles, and we've practiced from going from moles to mass and mass to moles. Well, today we're going to go from mass to particles. So we're going to start off with what we know and are given. Look at that as a fraction. And I want to convert atoms to a mole. You're always going to convert something to a mole before you can convert it to something else. All right? Or you're always converting from a mole to something else. So here we have atoms. Since I want atoms to cancel, it's going to have to go in the denominator. Remember when we did the particles to moles, we knew we have to divide by particles. Alright, so we've got atoms canceled, but we're left with moles. The question is, what is it in mass or grams? So I'm not done. It means I'm going to need another conversion factor. So I can see that for every 1 mole of iodine, I have 126.905 grams of iodine. So in your calculator, this just becomes 5.62 times 10 to the third times the mass divided by Avogadro's number. And we get an unrounded answer of 1.1843. It's longer than this, but I'm going to just stop it. Since we have 1, 2, 3 significant digits, 1, 2, 3, look to the right, we're rounding down, and so the final answer is that. Okay. All right, let's see what the next one is. So we're going from, again, things to mass, just like the one we did before. All right, so I know that 1 mole of sulfur dioxide is equal to Avogadro's number of molecules. And I know that the molar mass of sulfur dioxide is equal to a sulfur plus 2 oxygens. And we find that to be 64.04 grams of sulfur dioxide. So I'm going to start off with the given. And again, I want to convert things to moles, so I know I need to divide by Avogadro's number. And molecules cancels, I'm left with moles, it's 2. So I need to go from moles to mass, so I need to multiply. And multiply and then divide, and we get an unrounded answer of We have two significant digits, so 1, 2, look to the right and round up. Oh, I'm running out of room. Grams of sulfur dioxide. Okay. All right, let's look at the next one. So for this, we're going to, given mass, find particles. Grams, atoms. So I know that 1 mole of chromium has this many atoms. I know from the periodic table that 1 mole of chromium is equal to okay, so we're going from mass to particles. So I need to now divide by the molar mass. Left with moles, so I need to end up with atoms in the numerator. And now we just multiply and then divide, and we get an unrounded answer of we have 1, 2, 3, 4 significant figures. 1, 2, 3, 4. Look to the right, round up. Since we're adding 1, we're going to have to add 1 and add a 0. 1, 2, 3, 4. Look to the right, round up. Yep. And that is positive 23. Yep. Okay, so in 10.33 grams, which is less than a whole mole, I have less than Avogadro's numbers. All right, next one's set up just like this one. How many formula units are in 24.8 grams of potassium chloride? So 1 potassium and 1 chlorine has a mass of and of course 1 mole has Avogadro's number of formula units. We're going to take the mass and we need mass to cancel, so it's going to go on the bottom. I need moles to cancel, so it needs to go on the bottom. And we're going to multiply by Avogadro's number. So multiply, multiply, and then divide, and we get an unrounded answer of 1, 2, 3, 1, 2, 3. And that, my friends, is how you do mass to particles and particles to mass. If you need any more examples, just let me know and I'll do some more. All right, over and out. See you later.